So we are on to chapter 3.2, which is going to deal with Newton's second law. So quickly, let's just review Newton's first law. States that the velocity of an object changes only if an unbalanced force acts on an object. Just another way of saying that an object moving at a constant velocity keeps moving at a constant velocity unless acted on by an unbalanced force. Okay, velocity, unbalanced force. Those are your key words when it comes to Newton's first law. Okay, if you remember, what is constant velocity? Okay, means no acceleration. Remember, there are three ways to change acceleration. You can speed something up, you can slow it down, or you can change its direction. Newton's second law tells us exactly how the forces and the acceleration given the mass of an object are related. So it's going to be telling us the relationship between these three things: force, mass, and acceleration. So let's look at an example here. We've got Chris Carpenter of the St. Louis Cardinals, and we've got cutie Macy Falkavage of Milton Rock Giants way back when she was 4 years old. Okay, both of them are throwing a baseball. Okay, however, if we look at the force, the mass, and the acceleration, there are a few differences here. The mass is exactly the same. A t-ball and a baseball, okay, are exactly the same. The big difference is going to come, and I think we could all agree that Chris Carpenter is going to be able to apply more force to the ball than Macy Falkavage when he throws it compared to her. We can then reasonably conclude, in visualizing your experiences of watching Major League Baseball versus t-ball, that the ball that Chris Carpenter throws is going to accelerate. It is going to change its velocity a lot faster than the ball that Macy throws. Okay, let's take a different scenario. We've still got Chris Carpenter, but now we have Jenny Finch. I don't know what you guys know about Jenny Finch, but she pitches for the United States women's softball team and is an amazing pitcher. We are going to, for argument's sake, say that they can both apply the same force to the ball. Now, I don't know what you know about the mass of a baseball versus the mass of a softball, but the mass of a softball is greater than the mass of a baseball. Okay. How then do you think that is going to affect the acceleration of the baseball versus the softball? Which one is going to accelerate faster? Okay, so when force is held constant, okay, the mass and the acceleration have an inverse relationship compared to the Macy Falkavage example, okay, where the mass was held constant. So the force follows the acceleration. Okay, two different examples, very minute differences. The results are very different though. Okay, so in summary, what this is saying is the acceleration of an object is going to depend on the mass and the force. I think you guys could have figured that out, right? So we're just trying to build the layers here to talk about how these objects are related. Okay. So it shows us that relationship, but we haven't put it into true words yet. So Newton's second law states that the acceleration of an object is in the same direction as the net force on that object. What this is truly saying is force equals mass times acceleration. Okay, it's the formula that you hopefully worked with some on your pre-reading this week. Okay, our unit of force is going to be newtons. So this is going to give us a little bit of an interesting situation here where we don't have any derived units. So let's just quickly review our units. Okay, so force is going to be newtons. Mass, we're going to work with kilograms. And acceleration is going to be meters per second squared. Okay, these kinds of things you need to know because depending on what we have in this formula, you're just going to have to now know the unit. There's no crossing things out and figuring out what is left over. So let's look at a problem together. Again, we have a formula triangle that you can use, and you'll want to get that down in your notes, and that can help you start to work through these problems. So our first problem. Zookeepers lift a stretcher that holds a sedated lion. The total mass of the system is 175 kilograms. The keepers lift it upward with an acceleration of 65 meters per second squared. What is the force that they are applying to the lift? So my first step is going to be to identify my variables, my mass, my acceleration, and Mrs. Falkevich does not have a calculator nearby, so take those together, and what do you get? Okay, try another one. The net force needed to accelerate a car forward at 2 meters per second is 3,200 newtons. What must the mass of the car be? So here we're trying to find mass. So our equation is going to be mass equals force divided by acceleration. Careful on what the units are going to be. One more for us here. The net forward force on the propeller of a 3.2 kilogram model airplane is 7 newtons. What is the acceleration of the airplane? All right, that is going to be Newton's second law. For tomorrow, make sure you are ready for lab. The next 2 weeks, 3.3 and 3.4, we are going to be looking at very specific examples of using force equals mass times acceleration. So this formula is not going away, so if you have questions, make sure to ask them.